All right. So section 9.5 of this unit is called Creating References Using Inheritance. So look at these examples. You might think that in a hierarchy, you can only do things like this. Parent P equals new parent and child C equals new child. But Java actually lets you say parent P equals new child. What? So to put it in words, you can create a variable of a parent type, but you can store any of the children inside of it. You can't do it the other way around. A child can't hold the parents. So again, parent P equals new child. Why would you want to do this? Personally, I would probably try not to do it just because it's kind of a confusing concept. But there may be times when in your code, you need to be able to take any of a bunch of different child objects and store them in a single container. So without having to have multiple branches of code, like this one deals with child only, and this one deals with parent only. Like you're going to be combining all kinds of objects. So an example where we've already done this is with the store. Look at this. This was the code from the store test run code. It said array list product. So that's the parent class of all the different products we made. And notice we added 2 products and then a dairy and an alcohol, and then we printed them all. And notice on the print, we're saying product P from the store. And so this is a perfect example of when it'd be smart to do this thing where you declare the variable type to be the parent, but then you instantiate it as one of the children. You're allowed to add the dairy to a product. You just couldn't add a product to a dairy. So again, by setting up the array list using product, the superclass, we can store all the children, any subclass. And then that for loop can print any of them without having it be extra complicated. So here's an example that won't work. You can't say array list dairy and then try to add a product to it. You can't add parent things to a child. Here's another line that won't work. You can't say dairy dy equals new product because you can't make a dairy object point to its parent. These last two would work. Product dy equals new dairy or dairy dy equals new dairy, but you can't. Anyway, as long as you're storing a child in a parent or a child in itself, you're all good. Any questions? All right. So now a scary sounding title, polymorphism, but it's also kind of cool that we get to learn something called polymorphism. Polymorphism means having many forms. And in Java, this happens when we do method overloading or method overloading in a hierarchy. So the many forms part happens when children are doing different things with the same method call, depending on where they are in the hierarchy. So I created a whole sample. So you're going to want to look up here. We've got a class called the flying thing. And then we have a bird class, which extends flying thing. And we have a baseball class, which extends flying thing. And they all have a method that's a void method called fly. And if you fly a flying thing, it just says it flies, but it doesn't say how. If you fly a bird, it flies by flapping its wings. If you fly a baseball, it flies by being thrown or hit. And then baseball also has a fly with accepting a parameter, which indicates that it got a home run. So this is an example in a hierarchy of polymorphism. We could create a bunch of objects, store them in an array list, of flying things, and then we could ask each one to fly without us ahead of time knowing whether it was going to be a ball, a bird, or just a generic thing. And they could all fly. And so that fly method can be applied in your code, and it'll be many different things depending on what happens at runtime. So as with that store example, I created here an array list of flying things, called it airmail. I added one of each type, and then I did an enhanced for loop where I got each thing out of it one at a time and said fly, and then this would be the output. So notice the code down here doesn't know who's a bird, who's a baseball, who's a flying thing, but it can make them all fly. This is what we talk about with Java polymorphism. And you can look at this slide as much as you need to, later. Also, if you want to explore these ideas more, the AP Classroom has videos for section 9.5 and 9.6. You don't have to watch them, but if you want to understand it more, you can. So any questions?
What exactly is polymorphism again?
It's the fact that you can have, in a hierarchy, different classes in the hierarchy have the same method.
Okay.
And it does different things.
Got it. Cool.
So it seems like a really big name for a small concept. But okay, I'm going to pause the video. I'm going to assign that. All right. Check this out, everybody. You may have heard the term object with a capital O, but it turns out object is at the top of the entire Java universe. So every class we've ever made already was implicitly extending the object class. So when we make a book or a frog, even though it's not written anywhere, that's where things like toString and dot equals come from. They're up in the parent of everybody. Everybody's parent is the object class. So, and you don't have to use the extends keyword with our classes regarding object. So I'm going to Google the Java object class API and show it to you here. So I just clicked on it. Here it is for Java version 7. I'll move that slightly out of the way. Class object. It's the root of the class hierarchy. Every class has object as a superclass. So all objects, including arrays, implement the methods in this class. So method summary clone. There's an interesting thing. Equals, that's the dot equals. Finalize get class. There's a bunch of stuff we don't really care about, but here's toString. And if you go to public Boolean equals, it receives an object and it tells you if they're the same. And toString returns a string representation of the object. That's what we've been doing all along. So back to here. ToString, just talking about that for a second. ToString in the object class is what gets called when we write a custom class but don't create our own ToString method. It ends up calling object, and object returns that hash code, the @ symbol and the code. That's somebody had to be doing that, right? So it turns out it was the object class. And we've been overriding that ToString method with our own. Overriding is when you have a method with the same name as a parent. It does the child one instead of the parent one. So the only other object method that we care about is the dot equals method. For this class. So you know how we use double equal signs to check for equality with primitive variables? And I hope you remember that for reference variables, we use dot equals to tell if they're exactly the same. Here's an example. I create a frog A, and then I say frog B equals A. This is A and B are pointing to the same frog. There's only one frog. So when I use double equals here, it says true because they're literally pointing to the same thing. If I made two frogs that both were at zero location because they were brand new, and then I tried to do equal equal, it would print false because they're not the same frog. They're not even equal in terms of how far they went. Because double equals is asking, do these two variables point to the same location in memory? And that's not true when you create two different frogs. So bottom line, Java requires that we use dot equal to compare reference or object variables, classes, anything that's not primitive. And mostly until now, we've been using this to check if two strings were equal. Dot equals is defined way up in the object class. And then if you wanted to, you could see the value in creating a dot equals in a custom class. So I'll show you one I wrote for the frog class. And the point of it would be, are these two frogs at the same location? I mean, you're not gonna, if they had names, they wouldn't be the same frog. But right now, if you had frog A and frog B and you hopped them both 10 spaces and you did a dot equals, it would say false because they're not the same frog. It goes all the way up to the object class, and that's just checking, are these the exact same thing in memory? No, they're not. But we might want to have a thing that dot equals for frogs just meant, yeah, they're at the same spot. So check this out. This is a Cadillac version of the dot equals method that I wrote for the frog class. And we'll go over each part in detail. So starting at the top, if you're writing a dot equals method to override the one in object, it has to accept an object. You can't, even though we know we're doing frogs, we can't have it accept a frog. We're taking a generic object, and it doesn't have to be called OBJ, but in the examples here, that's what I'm calling it. And so just because you were doing a dot equals, if you did a dot equals in frog and you had it accept a frog, there's a certain logic to that, except then you wouldn't be overwriting the object class because it'd be overloading the dot equals method. There'd be two versions of it, one where you accepted a generic object and one where you accepted a frog. And we're trying to make this the one, we're trying to replace the one in object with the one that we want in the frog. So first thing to do is see if what got passed to you is null. Because if it's null, you can't do any checking of like, are the variables the same? You just say they're not the same. Like here we have a frog and you try, hey, is this frog the same as null? No. Return false. Then next up in the Cadillac, I say the Cadillac version of dot equals, this has like every single thing you could ever do. There's actually a get class call that tells you what class an object is from. So this is checking, hey, if the class of the current object and the class of the thing that just got sent in are not the same, then obviously they're not both frogs. They're not the same frog. Then we have to cast the OBJ into a frog because it's an object right now. Just like we cast a double, an int into a double, or a calculation into a double by doing double in front with parentheses, you can cast something into a frog. I mean, of course, only if it is a frog. If you tried to cast an int into a frog, I think it would just say can't do that. But this OBJ, we know at this point it is a frog. So now we can start talking to it as a frog. See, the first line, we don't know it's a frog. Is it null? If it is, bail. Are they both of the frog class? Those first two checks are fully legit with anything that got sent in, and nothing would crash. Then, now we know it's a frog and it's not null. We're going to cast it to be a frog, and now it's called other instead of OBJ. And then now we check if their locations are the same. And if they are, we return true. That's the way I'm defining two frogs being the same. They have the same location. And then otherwise, if we get to the very end of it, we return false. And notice it says other dot location equal this dot location. This being the first one in the dot equals expression, like frog A dot equals frog B. Frog B is the other, the OBJ, and then it turns into other, and frog A is this one. That's where the code's running. You don't need to put the this there, but it's you do have to say other. Otherwise, you'd be comparing the location variable in the first frog with itself, which would always be true. So yeah, finally we return a false if we haven't returned yet. So the key parts to the Cadillac version, full complete version of a dot equals method, check if the object is null. If it is, return false. Make sure the object and the current object are the same class. If not, return false. Cast obj to be the current class type, in this case frog. And then finally check all instance variables for equality. And if they're all equal, return true. So you can imagine if you had a student class, had a first name, last name, and grade level, you'd have to check 3 variables, make sure they were all true, they were all the same before you said, yeah, these 2 students are the same. I'll post a link with the frog class dot equals. I said now, but not right now. So I'd like you to play with it a little bit. Let's see. Yeah, I don't want to do it yet. I'll do it in just a sec. So you don't have to write you're not going to have to write a dot equals method for the AP test, but they might have you read one. And so I want you to understand how it works. And you need to know that by default, it's inherited from the object class way at the top. And if I wanted to do the absolute minimum, this would be acceptable. Although just read my instructions like on the test and on our worksheet when we have one on Friday. Make sure you're doing what I ask, because the absolute minimum is public Boolean equals object obj, cast it to be a frog, check that the instance variables are the same, return true or false. So this assumes no one would call a frog dot equals with null or with a piece of text or with a number, which is fair. But today, once I want you to write the full Cadillac version, with all the checks, and you have the slide deck to help you with it. So let's said I was going to show you this. I think I'm going to stop the